Hey, this is Jonathan. So I've done some revisions since last time. I actually tried uh, recording and logging some of my progress on this a bit earlier, but that footage had no audio whatsoever. Just like everything I said just got swallowed up into a void for some reason when I looked. Like once I actually tried editing. So yeah, I don't know what happened there. Anyway, things that have changed since last time. Bitflags gone. They're out the window. It wasn't gonna work. Reason being, we don't have enough bits. So you can go. So in Rust, you can define up to 128-bit integers. So you can go like U128, but if you go U256 or higher, no, nada, nothing. And that isn't really very flexible or going to work for our locations, because typically you have a lot of locations, like a lot of different item locations. So they're all going to be unique. And yeah, just having like, I don't know. So the example I was giving earlier was, I think A Link to the Past has like 216 items in total. And like a crossover randomizer might have up to maybe 300 locations that you can check. That's a lot more locations than number of bits available to us. So that doesn't work. So yeah, I did some experimentation. Doesn't look very viable, unfortunately. But on the bright side, at least we can reason with things a little bit more easily when they're just enums. So that's kind of cool. That's cool, I guess. Also, I changed the count items because I realized that trying to do that iterating thing, actually that iterating thing wouldn't have worked anyway. At least not the way I was doing it. I would have had to use recursion to implement it that way. And Rust doesn't support tail call optimization, so there really isn't much point in doing that. I mean, I guess it wouldn't really overflow the stack if I had to count, I don't know, like 120 times or something, but still. I don't like having, recursion in a place where there is no tail call optimization. It just feels like I'm just asking for problems. So yeah, I figured out that I could just use math instead, and just use like a log base 2. Like I could have taken the bit representation, did this log base 2 of that to get the number of bits or the number of items, and then add 1, of course. But since that approach is pretty much out the window, that's not going to work either. So basically I had something that was kind of clever and could have worked if we had less locations to worry about and less items. And I mean, in theory, the game that I'm making, or any good randomizer game, might not actually want to have as many items as A Link to the Past does, because like A Link to the Past runs, they take like, I don't know, at best an hour, I would say, just over an hour, to typically 2.5 hours. Maybe closer to 3 if you're a little bit less skilled, or it's a particularly bad seed. So I don't know, like maybe that number of locations isn't good to have, On the other hand, the game world could be made more compact somehow. I don't really know. So that's another thing that I could do. Or have the character move faster. That's another thing that would cut down times. But yeah, I mean, it depends on like the length of the game that you're aiming for. And we want to have flexibility. So I decided, let's just go with the enum. Stop trying to do clever things and just, bite the bullet. Go with the enum. So, I guess if we're gonna do an enum, we're gonna have to define our items again. So we'll just be like, I don't know, item 0, item 1. Oh yeah, this yeah, this is not Python. You won't be getting away with using white space like that. So yeah, we'll have our items defined here like this, and we'll have our locations defined similarly like this. I just said it's not like Python. What am I doing? I'm just like, oh, use the white space. Yeah, that'll definitely work. New lines can delimit things, right? And we probably are going to have to implement partial equality, because if we're going to check if an item, or like, yeah, if we want to check, well, actually, are we going to have to do that? I think we would, because we're going to have to check. Well, actually, I'm not sure. I thought I was going to do partial equality because of what I was doing earlier with the bits, but since I'm not doing that, not doing it that way, I might be able to get away with not doing like a contains check. I doubt it, honestly. I'm probably gonna have to implement it at some point, but let's not get too far ahead of ourselves. That's a problem for future me, I guess. Right. Other things I figured out. If I have the item count, I can do this little for each thing, and yeah, that would have been cool. I mean, I can still probably do this. I don't think I would want to change item count necessarily, but count items, it's going to be a lot easier when we have like a vector of items, obviously. So yeah, we're just going to go ahead and ignore that. Just get rid of that, because we're going to be able to create a big, long, honkin' list of items right here. It might be better to just define this as like some kind of constant or something. Can you define like a heap allocated vector as a constant, though? Does that work? I'm not really sure. You can tell I don't really play with a lot of low-level languages that much. I mean, I guess we could try, right? How could that possibly hurt? You can just do it. Okay. I don't know. Const items is a vector of items. Oops, what am I doing? It's not at all going to work. Right, I see item 0. What? Nope, it resolved the reference. That's fine. It's just a little bit slow. Constant n should be uppercase, like items. Oh, you're right. It should be uppercase. I don't know why, but that's just the style guideline, I guess. Yeah, the other not so nice thing about this approach is I don't get to do like the item set.all anymore. I have to actually just define like a constructor like this, or not define a constructor. I actually have to just construct all the items into one big vector manually for every item, and that kind of sucks. Yeah, that kind of sucks. Because now I have to modify 2 places every time I want to add a new item. I have to modify this, then I have to go and modify this. I guess what I could have done is define each item as like a number or something. It's a list of numbers. I don't know. Does that seem like a good idea to you? I don't know who I'm talking to. I just don't feel like this is the cleanest solution I could have come up with. But it seems like it works. It seems like it's okay with this. Probably because this is a... So what's nice about this is it's a macro, so this is all done at compile time. That's kind of cool, I guess. Let's see if I can do something like... Oh, I don't know. Well, this item set thing doesn't exist anymore, so I can't do that. Can I do this? Probably. Maybe not. That's private. Oh yeah, everything's private. That's right. I shouldn't do that. I want everything to be public, right? Yeah. Location set doesn't exist anymore. This has got to be a pub enum. I probably want to do the same thing there. I love how we now have like this red text and stuff to tell us that, hey, this is wrong. I feel like that wasn't a thing that IntelliJ Rust had before. I've been using it for several, well, not well, yeah, I have been using it for like a couple of years now, and I've been noticing the rather rapid improvement, and I'm liking what I'm seeing. It really is starting to shape up rather quickly. Because before I wasn't very good at catching mistakes at all. I was just letting so many things through. Now it actually, yeah, now it actually helps me out a lot, I find. Catching errors before I actually, you know, have to manually compile. So it's nice. It's just a nice quality of life thing. It really makes all the difference to me. Okay, let's see if we can do this. I can do that. Very cool. It's a little bit slow, I have to say. A little bit slower than I would have thought. But, I mean, it does its job. It works. It's faster than manually building it, I think. Wow, yeah, that's kind of slow. It's okay. We'll live with it. Alright, we have the length. The length is... Yeah, the length is always a usize for some reason. Can't really remember the reasoning for that. I know that usize is used for, like, indices into array-like structures, so maybe that's why? I don't know. You can't do this. That doesn't exist anymore. We have to use locations. Yeah. Instead of shuffling the count, I can just shuffle the locations directly. I don't need to do, yeah, I don't need to count the locations at all. So yeah, we will be basically doing what they have done in the other place, I guess. Or at least roughly the same thing. In that document. Yeah, that's what I meant. Except this doesn't exist, because I haven't imported it. There we go. Contains item is gone, isn't it? Yeah. Guess I don't need that. Okay, okay. Oh, I think I am gonna have to do like a contains item type of thing, aren't I? Because we have a vector of items. And then I want to check. Am I going to be checking the assumed item list? Okay, so hang on. We have a list of accessible locations. And then when we pick an item out of our items accessible list, we're going to remove those locations that item unlocks from the locations list, because obviously you can't have the item locked behind itself. That just doesn't make sense. But we also want to make sure that we've gotten rid of all the locations that we've already put items in. So we basically just need to keep like a running list of locations. Yeah. That seems like the right approach to take here. Okay, yeah, I think that makes sense. And we're just gonna keep doing this RNG shuffle, I guess, over certain things. Or no, we don't need to keep shuffling. We only need to shuffle once. What am I talking about? Shuffle the list of locations once. And then, I guess, shuffle the items? Does that make sense? So, should I shuffle the items? I guess I could shuffle the items and it probably wouldn't really make a big difference. Yeah, I don't really see what the big deal is there. Also, I can inline this. I just realized this. Can we inline that? Right here? Yeah, I think so. Although, borrow checker. Right. Maybe I don't want to do that. Because this, I think, would immutably borrow items accessible here, and then for the rest of this scope. I'm not entirely sure. I'm actually not 100% sure on that. But just to be safe, I think I'm going to do that. I don't really feel like fighting the borrow checker. Although probably would be a good idea to get a better understanding of how it works. So yeah, I'm not going to do that. Not for now. Oh boy. So shuffle returns void, or sorry, not void. Unit. Yeah, void and unit are not the same thing. Don't forget that. They really are not. This returns unit, so what I think I want to do is make this a mutable list of locations. Yeah. We'll shuffle the locations. I guess I should also make the other thing mutable too, right? This? If we're doing shuffling? I'm not really sure if shuffling is the best way to go, honestly. I mean, like, it's probably not going to make a really big difference. But I kind of want to limit the amount of mutation I'm doing, just because it makes things a little bit more difficult. But then when I have RNG in here anyway, it's not really like I can do very much about that. Yeah, I'm just trying to think. Like, what are the possible outcomes here? For now, I guess we can shuffle. I think there's still a way to make this work in a at least somewhat functional way. Yeah, I don't really like the idea of passing around mutable references all over the place, but let's just do this for now. So that's how you run into trouble with the borrow checker. Yeah, and also I just kind of generally like having more, I guess, expressive code. Yeah, we're gonna shuffle the locations. I guess we can shuffle the items. Maybe I should do that before I enter this thing. Do you think that matters? It's probably okay. Right, so I think that this algorithm has to make certain assumptions about the game. Obviously, when you're running an algorithm for, say, like a randomizer algorithm for A Link to the Past, A Link to the Past is a very specific instance of a game that would have a set number of locations and a set number of items, so you never have to worry about that. Like, those are invariants. In this case, where we have more control over that kind of stuff, we have more creative liberties, I guess. We probably would want to make sure that there are certain invariants that hold for us as well, because obviously if we don't have enough locations for the number of items, we're going to run into problems. And I think something similar could happen if, say, like we have an item like, I don't know, let's say item 0, in our case, gets picked first, and item 0, for some arbitrary reason, locks, like, everything except for one location. Like, if we had an item like that, and that got picked first, it would be removed from the assumed accessible list. At least I think that's how that works. I'm pretty sure that's how the algorithm works, right? Like, you put... You basically need to have... You need to make sure that you have enough locations left for all the other items. So your item list cannot be cut down to a certain size. Otherwise, you're in trouble. And you'd probably have to, like, reseed or something. At least using the existing algorithm. I guess you could try and put in some guards in place to make sure that doesn't happen, but yeah. I feel like it's just safer if you have some invariants. Anyway, that's just more like looking at this from a theoretical standpoint. Obviously, we're going to have to deal with that in the future. But for now, I think we should be okay. I don't want to be shuffling every single iteration. That seems like that just seems crazy. Shuffle our items. Alright, so now we've shuffled our items, we've shuffled our locations. And now we're going to do stuff with them, I think. Right, so we're going to have to filter the locations based on the item that we pull out. And a vector is basically a stack, so I can just do like a items accessible.pop. Oh wait, that's going to actually mutate it, isn't it? Is that what we want? I guess that'll work. I'm not really sure this is actually going to work, because it might complain about this mutable borrow up here conflicting with this one. Even though they really shouldn't conflict at all, because, I mean, these are like completely separate. Like, this, after this returns, it should let go of this borrow. But anyway, let's just go with this for now. Oh, that's an option item. I'm glad that this told me. Yeah, because we're gonna have to deal with whether or not it's null in that case, which is kind of annoying because there's, well, actually that's not true, because we, I guess, theoretically could run out of items. Sure, let's just do an if let here. Okay. We want to take the item out, but we also want to drop the locations. Yeah. So for our locations, I think we should have like some kind of like drop locations function that just takes like a list of locations and then, you know, well, drops them. That kind of makes sense. And it also has to take the item. Yeah, okay, I can do that. So it's going to take what? I don't know, mutable reference to a vector of locations. We're going to take an item. Here's an immutable reference to an item. What don't you like about location? Unresolved reference location. Oh. Probably should do that. I know it can't. I'm being silly. Stop bothering me. I'm being silly. Yeah, so we take our vector of locations, we take the item that we're going to remove the locations for. And I thought we were going to take a third argument, but now my brain has completely forgotten. I think that's it, actually. We just want to return our vector of locations, I think. Alright, so we're just gonna... So we need to somehow determine which locations the item unlocks. That's a very dangerous way of thinking. That wouldn't work. So if I just had like a mapping of item to location it unlocks, this doesn't account for cases where you need two different items to unlock a location. It would be able to easily handle cases where only one of multiple items is required, sure. But it would not be able to easily handle the case where you need like both the fire rod and ice rod to like kill Trinex to get his item. So there's a there's a little trap to look out for right there. So this isn't sufficient information, is what this tells me. We probably need more than just the item. Knowing the item is nice, and we definitely need it. But that doesn't tell me which items, or which, that doesn't actually tell me which items it unlocks. So yeah, that is kind of interesting, now that I think about it. So, how do we encode this? Well, what they do is they filter out locations based on what? I forgot already. What do they use? Can the item be placed there given the list of assumed accessible items? If not, filter it out. Yeah. So we do have that list of assumed accessible items. Now, unfortunately, we're mutably borrowing it here. So trying to pass that in directly isn't going to work unless we clone it. Because, yeah, otherwise we have two mutable references to the same object, and that's no good. That's kind of why I wanted to do things in a more immutable fashion. And I think that is still possible. I would just have to like refactor this a little bit. That seems like something I might want to do. But like strictly speaking in terms of this drop locations, like just ignoring the borrow checker for a moment. Well, what's the rough outline of this going to look like? Well, we would probably want to do something like locks.filter. Well, it'd probably be like locks.iter.filter. And in this filter block, we would take our location. I could multi-line this. I don't really feel like it. Because then, you know, comments. Yeah, we're going to have to filter the locations based on, I guess, is accessible, whatever that is. So they filter items out. Or, sorry, not items, locations out. Based on assumed accessible items? Okay, I just need a moment to think about how that actually works. Because let's say we're taking out the hook shot. I really like the hook shot as an example because it's a really cool item. So if we're taking out the hook shot, let's say that this item is hook shot. Everything else would be assumed accessible, right? Because we have to take that item out of assumed accessible. Yes. So there's something important. Yeah, well, because we do just pop this from this stack. So it's no longer in the items accessible, but because it's we're mutably borrowing it here, we don't actually get to play with it here. So that kind of sucks. That really sucks. I know there's a way around this, but yeah. So we're going to have an updated list of assumed accessible items without the hookshot. So it's basically everything but the hookshot. And somehow, based on that list of assumed accessible items... Oh boy. Can that be placed there given the list of assumed accessible items? If not, filter it out. Okay, so somehow we need to do something with this location in here. With I guess we could check so if every location has some kind of like is accessible method or something. I don't know. Well, let's just entertain that thought for a bit. Like maybe every location has an is accessible method, and it just takes an item, or like the assumed accessible list at the very least. And maybe, oh boy. Yeah. Let's just say it takes an item. And the assumed accessible items list. If we could get that somehow. Actually, does it matter? No, that doesn't matter if it has the item or not. Why would this play a role in whether or not the location is accessible? Remember, we just removed it from our pool of accessible items. It doesn't matter. It's a non-factor. So no, this is not the way to go. What I actually should be doing is taking that list of assumed accessible items. Okay. Yeah, and then we can treat the list of assumed accessible items as like an inventory of sorts. The location will do a check and take an inventory, and it'll check if we have certain items. If has, I don't know, like fire rod and ice rod, then it'll keep that location because our inventory is only missing the hook shot. But if it says this location needs a hook shot, it'll drop that location from the list. Okay, that seems a lot simpler, and we also don't need to do this anymore, I think. Yeah, we can just drop this entire thing. Ta-da! We're going to treat that like this. Instead, we're going to take a vector of items. This is our items accessible vector right here. And because of this mutable borrow being dropped at the end of this call to pop, we should be able to just drop locations, passing in our locks, our locations, and our slightly smaller list of items. Of course, we want to make sure this is also a mutable borrow. We don't want to drop that list just yet. We won't need it for subsequent iterations. Which means we need to... What's the error here? Let's just be sure. Yeah, okay, that's what I thought. We need to do that. What is this? Okay. Interesting. Oh, wait! Oh, I put this in the wrong place, but then that makes this valid. Fascinating. I don't think that's what I wanted to do, though. I think I actually wanted it to be here. Because I think that would just consume it then, and then it would turn into a mutable borrow, but that wouldn't be what we actually want to do. That's... Yeah, the semantics of that are different. So don't do that. Do this. And probably actually keep this thing that I'm trying to do. Yeah, because we are actually going to be filtering out locations. Okay. Oh, this is so nice. Normally when you're doing like iterator, like maps, filters, and folds and stuff, the borrow checker requires certain things, and you get like multiple borrows like this, and like I had to like kind of memorize the different scenarios before of how this could arise, but now like IntelliJ Rust is smart enough to actually just be able to tell me this stuff up front, and that's really awesome. That's so nice. Because yeah, it definitely didn't used to do that, so I'm very happy to see that. I think I want to do this thing that people do. Actually, I probably just want to... I can leave the iter there. We'll just leave the filter down there. Anyway, that's just style. It's not that important. Again, we can just do this is accessible type of thing. given this list of items. Oops. Yeah, actually, we no, wait, no, it's already a mutable borrow. I don't need to convert it. That's the type. Items. Items. Yeah, this would return an iterator instead of a vector, so I'd have to do a dot collect at the end. But maybe I do want an iterator. Maybe I don't really want a vector right now. I don't know. For now, it's easier to reason with it if it's collected. So we're going to do the dot collect as a vector of locations. Oops. No wonder. That's not a type. This is, but that locations is not. That's not valid. Oh, it doesn't like... Okay, nope, now it's happy. Yeah, so we need to... I know I could just avoid doing the turbofish by like assigning it to an intermediary or intermediate variable and then just returning that, but nah. I like the turbofish. Yeah, we want to make sure that it is accessible given the items that we have. And every location is going to be different. Yeah, how's that gonna work? Didn't really think about that. Actually, I'm not really sure if an enum is what I wanted to use for a location then. Maybe I wanted it to be like... Yeah, maybe I wanted it to be like a trait. Like a trait bound on this. Like if it has... Yeah, maybe I could have had like a location trait in the location object. I'm not really sure how this is going to work. Because I can't impl for different variants of an enum, right? Like if I'm going to do an implementation, an impl for my location... Wait, can I? I forget how impl works. Impl location 0? Does that work? It does. Oh, I am able to do impls for every single one of these. Okay, that... Huh, okay. Sure. Like, that's cool, but... I still need to have, like, a general... is accessible, right? Like, I need to do the is accessible for all of them. So I'd have to do, like, an impl location is accessible. And then each of these variants would have to implement that? Like, is that even possible? I don't think so. Because an enum isn't actually an enum isn't a trait, right? So maybe instead of having location be an enum, what I should do is have every location be a different struct. And then have this impl. Yeah, and then I can impl the location trait for each of the actual locations. And the location trait will have a method called, or a function called is accessible. And it takes like the list and boom. There we go. I think that's the way I want to do this, actually. So yeah, let's take a moment to re-thingamabopper. Rethink. Reduce. Recycle. No. Well, maybe. If you really think about it. Or don't. It is accessible. Okay. And it takes a reference to itself and returns a boolean. Oh, and also takes a list. Or a vector, whatever. I mean, this barely matters. Whatever. We can even ignore that for now. I don't think what I'm trying to do is possible, is what I'm saying. No, I can't define a stub. This is an impl. This is an implementation. Duh. Okay, yeah. So yeah, what I'm trying to do doesn't work. What a surprise. Okay. I understand what I'm trying to do, and I also understand that it's completely wrong. Anything about items that I should care about? I guess it depends. Do items have functionality? Do items, care about anything? I don't know. I guess I can leave the items as an enum. What harm could that possibly do? Yeah, because this allows me to kind of treat them polymorphically, and it's everything, all these things are an item, and just have a collection of items. That's nice. I like being able to do that. Yeah, that's the thing about locations. If I use a trait, then how am I gonna store them here? I guess I could store things that implement the trait location. I guess that works. That's a thing I can do. Let's try it. There's not really much I can lose from just, trying it, right? So there are going to be some limitations here. I'm pretty sure that everything has to be the same size if I want to store it in a vector. I mean, this works for an enum because all the variants are the same size, or they're always the size of the biggest variant in the location, memory-wise. But when they have arbitrary structs that implement a trait like that, I have to make sure that they are definitely going to be the same size. So to do that, well, yeah, oh gosh, now I'm starting to question if it's a good idea to do this struct thing. I guess I can do that. I'm really not sure now. Really not sure. We're gonna try. We're gonna try. If it don't work, then oh well. But if it does work, then hooray, I'll be happy. Yep, do that. That's all I need. Oh, yes. Do that. This is going to be a stub. And we're going to have a bunch of structs. How about, I don't know. Let's make this a public trait as well. Struct. Location 0. Struct. location 1, struct location 2. These could just be tuple structs, honestly. And then for each of these we'll have a separate impl. This is probably not the best solution, but I think this will work. There's probably something else I could have done. But I mean, I want different implementations of, like, is this location accessible, right? And this just seems like the way to go. I don't know. Oh, I forgot this. That's the important part. Let's just say this one is always true. Let's just copy this down here. Yeah, there's surely a better way of doing this, but I don't know. I can't think of one right now, so I'm not going to bother thinking of one at all. Let's get rid of location 2 for now. Let's do this, maybe. Yeah, how about that? Does that seem okay? I think that's okay. Can I do this? I don't know if I can just do that on its own like that. I am not sure. I'm really not sure. Okay, what's this? What's this error? One error found. Oh. What? Expected a vector of items, but oh, right. We get a mutable borrow of items because we don't want to consume our items right away. That's a good point. We do not want to do that. What? Is it because... Oh, this. Didn't change the signature for the base trait. Okay, this should update, right? There we go. I guess we can run it and see what happens, right? Drop locations, returns the vector of things. That doesn't really matter, we're just gonna do that. If it doesn't complain during compilation here, then... Oh. Oh, I don't need this anymore. Wow. Yeah, that's a thing. No, the size for the values cannot be known at compilation time. It doesn't have a size known at compile time. Ruh-roh. So what if I don't do this? What if I just create that vector later I'm not sure this is gonna work. I am not at all sure that's gonna work. We're gonna try. We're certainly gonna try anyway. I'm not at all sure that's gonna work though. Oh yeah, no. Oh no, oh no, oh no, oh no, oh no! Everything's blowing up in my face. There's definitely another way to do this. Maybe I could make this an enum anyway. You think that would make sense? If I just did this as an enum, and then impl this trait for each variant of the enum? I think that would make sense, actually. And then we'd have it the type known. This is getting kind of messy. I know there's a way to do this, though, like... That's just a vector of location zeros. No, how do trait bounds work again? I can't remember. Ah! Okay, yeah. Okay, can I do this? Does that work? I think that doesn't work. But I have to try. No, that doesn't work. Okay. I'm wondering if I can, like, implement this standard marker sized trait or something. I feel like there's a way to do something like this, but maybe not the way that I'm doing it. It just seems so doable, though. Yeah, I'm just not 100% sure. We could just make it an enum, though. And I think that would solve our problem. So if we make this an enum location... and we implement accessible... Yeah, sure. Then we drop these structs. Like, what if I did this? And then went like location 0, location 1. Then here I could have a list of, instead of this. Oh god, what? That's not what I wanted to do. That was weird. Don't do that. Stop that. I could take a list of or a vector of locations. I just calling them lists, okay? Jeez, I know they're not the same thing, but you know. Like intuitively, they function roughly the same, okay? And then we can just go like location, location. Yeah. Okay. Let's give it the accessible trait here. What do you mean I can't access those? Oh, okay, there we go. It's just a little bit slow. Yeah, we take a vector of locations. And then we check if the location is accessible. Well, we probably have to dereference it a couple times before we can do that. Although, is accessible... what does accessible do again? It takes a reference, so actually no, I only want to drop one of those. Oh, and I think I need to do this because of precedence. Yeah. That seems right. That seems like it would work. Let's try it. Oh, you can't do that. You expected a type, but found a variant. Ah, so that's why that doesn't work. You can try using the variance enum. I would do that, but I don't think that's going to work for my purposes, you know? Just saying. Well, anyway, that's kind of the state of where we are right now with this. I think we are making progress. We have an idea of how this will all work. Like, this is the rough algorithm here. So next time, we'll just continue implementing this, and hopefully we'll have an idea of how to solve this little issue that we're running into.